Hi there, and welcome to another video tutorial. In this session, we will be designing and constructing an automatic changeover switch with auto-generator start and stop, as well as IoT display and control. We will be demonstrating how the project works using this setup up here. We have two sources of energy, one from the public utility grid which is represented by this socket extension and the other from the generator. When there is interruption in the public utility grid, the design switches to the backup generator automatically and turns on the generator. If the switching and turning on was successfully, we will get an SMS alert. If there is restoration of power from the utility grid, it switches back to the utility supply and turns off the generator automatically. We are using the knife switch here to cause an interruption or restoration to the power from the utility grid. The knife switch is acting as the switch to the grid substation. The light bulb represents the load in the household, and we use the GSM module to send and receive information to the IoT dashboard. We have the LCD that shows us which mode or source the design is on and the energy parameters displayed on it. We can equally view this energy parameters on the IoT dashboard. Now, to get the list of materials and components used for this project design, click on the link in the description below. Here is the table listing the engineering materials. The link provided below has more details on the components themselves, like the 20x4 LCD module used here, the 2-channel relay module, the amount of current they carry, and their voltage capacity. The schematic diagram link is left in the description below. This is the PCB diagram of the board used for the project design. You can request for a copy of it by chatting us up or leaving a comment in the comments section below. We have already done a previous video on the assembling and soldering of this automatic changeover with auto generator start and stop. You can watch that video in the playlist before watching this one. Now, we proceed to the cable management and casing for the project design. During the program testing of the IoT-based automatic changeover switch with AutoGen start and stop, we programmed the design to try starting the generator 4 times sequentially, and if at the 4th time, the generator wouldn't start, the design would stop trying but would send an SMS telling the user that starting the generator was unsuccessful and perhaps a technical fault has ensued. We can show this by interrupting this grid supply here and using this generator as an example.
Let's
We can see that it tried starting the generator 4 times and after the 5th trial, it stopped trying.
push.
Now, let us get a better functioning backup generator and do a proper testing. Remember, we are using this setup to test the automatic switching of the design from utility power lines to the backup generator power lines when there is an interruption in the utility grid. The socket extension serves as the utility grid supply. We connected them as such. We are sending and receiving SMS signals through the GSM module with its antenna showing here. The light bulb represents the household appliance. When we turn the generator ignition on, and power the system using the 12 volts power supply from the generator battery, the design would sense that the utility is interrupted as shown by the switch at neutral. The system can turn on the generator.
No help.
And since the generator breaker isn't turned on, the current consumed by bulb and its power factor wouldn't be shown on the LCD screen until we turn the breaker on. And of course we will get an SMS that tell us that the generator has been turned on. The display on the LCD shows what mode of supply the design is on and also show the energy parameters of source. Now, we try simulating for when the grid power has been restored by flipping the knife switch to the utility grid source. This would automatically turn off the generator and transfer the power supply to the grid source.
So it has turned it off now. And it's on utility.
We can equally monitor as well as control the device from the IoT dashboard. That is to say, supposedly we want to turn the generator on from the dashboard, we can just turn the button on here. This will send a signal to the device using the internet on the Wi-Fi ESP01 module and the generator will be turned on. Through the same online button, it also allows you to turn the generator off on the IoT dashboard. You can also host the IoT dashboard on Blynk as shown here.
Alright, so let's check for when public utility is interrupted. It's still on public utility and it's displaying the value of the public utility. Alright, so let us interrupt it. So go ahead. So you interrupt. So when public utility is interrupted, so it will come on by itself. have to set up using the generator. So this particular generator here. Alright, so we're going to be dragging. We're going to be using this from the NEPA substation. I'm going to be taking another external power. Alright, so let's run that. So alright, so go. It has started generating on its own. It was no help. So you can see that we go over here and you shoot this. So it has turned it off now, and it's on utility. Alright, so let us interrupt it. So go ahead. So you interrupt. So when public utility is interrupted, so it will come on by itself. And it has started the generator. Alright, so let's check for when public utility is interrupted. Public utility, and it's displaying the value of the public utility. Alright, so let us interrupt it. So go ahead. So you interrupt. So when public utility is interrupted, so it will come up by itself. It has started the generator. Now, okay. All right. It is going to stop. So if it stops, it will still tell us back that it is on public utility. And that's that. So, okay, so let us say it was interrupted and we want to start it from online. So We want to start it from online. See, yeah, so let's go start it from online. Laptop. Let's see. You signed up? Oh yeah, leave it.